Yeah, in this lecture, we will prove the theorems which says that when we have two subspace W1 and W2, we have subspace of vector space PF and which is finite dimensional. It means cardinality of basis for W1 is finite and cardinality of basis for W2 is finite. Then dimension means, what is the dimension? Dimension is the cardinality of basis, and we also know that W1 plus W2 is a subspace of vector space PF. We have proved this in previous lecture that W1 plus W2 is a subspace and it is the smallest subspace containing W1 and W2 also. Okay, so it says that dimension of W1 plus W2 is equal to dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. And here this is also subspace because intersection of two subspace is also a subspace. So we have here four subspace. First one is W1 plus W2, second is W1, third is W2, and fourth is W1 intersection W2. And we need to prove this relation for the dimension, and it is very important. Okay, one should know in linear algebra that this is the very important theorem. Okay, now we will prove it. Okay, so assume first we will assume that u1 u2 um be a basis of w1 intersection w2. Means we have a subspace of vector space pf, and we assume that we have a basis, any basis, it can be any basis of w1 intersection w2. Okay, so cardinality of this basis will be dimension. It means dimension of w1 intersection w2 will be m, because we have m vectors in basis. We have m vectors in basis. It means that dimension of w1 intersection w2 equal to m. Okay, now as u1 dot u2 um is a basis for w1 intersection w2. Since this is a basis, it means this is Li, u1 u2 dot um is Li, and it is a spanning set for w1 intersection w2. Since it is Li, so and u1 u2 um are in w1 because it is in intersection, so it will be in w1 also and it will be in w2 also, and it is Li. So u1 u2 um, since it is Li and contained in w1. Okay, so because of w1 intersection w2 is a subspace of w1, so its basis can be extended because its basis is Li and contained in w1, so we can extend for the basis of w1 because it is contained, is a subspace of w1. Okay, so u1 u2 um can be extended to form a basis of w1. Okay, so we have new set of vectors u1 u2 um, and we added j vectors in the previous basis, so we have new set u1 u2 um comma v1 v2 vj be basis of for w1. Okay, we extended the basis of w1 intersection w2 to form a basis of w1. Similarly, this vector are in w2 also, w1 w2 u1 u2 um are in w2 also, so it can extend for a basis of w2. Also, it means what? U1, U2, Um, and we have extended k vectors 1 to k, which name is W1 dot WK. So all these vector as base is a basis for W2. We are doing extension here. We have li set and we are extending for a basis of some vector space. Okay. So here we have written same thing, U1 dot Um are in W2 and it is Li. So it can be extended to form a basis. Okay. Now we have dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2 equal to, we have dimension of W1 is, so as we have basis for W1, basis for W1 is U1 to Um, V1 to Vj, so M plus J. So we have M plus J is dimension of W1 and M plus K is a dimension of W2 and dimension of W1 intersection W2. What will be the dimension of W1 intersection W2? We have written here is M. So I have subtracted M. Now this M can be cancelled out. So what will be the resultant? M plus J plus K. This is nothing but RHS, what we proved. And LHS was dimension of W1 plus W2. So if we able to prove that dimension of W1 plus W2 is M plus J plus K, then we are done, because if we will able to prove that it is equal to M plus J plus K, then both will be equal. This and this will be equal. Okay. So here we are trying to do same thing to show dimension of W1 plus W2 equal to M plus J plus K. Okay. Now we collected all the vectors. We have collected all the vectors U1, U2, Um, V1, V2, Vj, W1, W2, Wk. This was the basis. Remember, this was the basis for W1, U1, U2, Um, V1, V2, Vj. We can see here U1, U2, Um, V1, V2, Vj is a basis for W1, and U1, U2, Um, and W1 Wk. These vectors, this and these vectors is a basis for W2. So this whole vector will span W1, because from here to till Vj, U1 to Vj can span W1, and this vector, these vectors and these vectors can span W2. So all the vectors can span W1 and can span also W2. Okay, so we have written here only. So U1, U2, Um, V1, V2, Vj and W1, Wk spans W1 and W2, and since they can span W1 and W2, so if we take any vector W1 and we can any vector, let's say is V1 from here, this belongs to this one, so this can written as linear combination of these vectors. This is also can return the linear combination of these vectors, all these vectors. So if we add, we got the vector from W1 plus W2. It means what? These vectors can span W1 plus W2. Okay. Yeah. Please understand this. these vectors can span W1 and can span also W2. So if we add all these vector which is spanned by all these vectors and these vectors, we can get all the vectors from W1 plus W2. Okay, now this is the spanning set. Now we are trying to show this is Li, then this will be the basis, and cardinality of basis will be the dimension. And if we see here, the cardinality of this basis will be m plus j plus k, m plus j plus k, what we are trying to prove. Okay, so we are done. If you would able to show this is Li, so now we are trying to show all these vectors are Li. Okay, so assume a1 u1 plus dot 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 am um plus b1 b1 plus dot dot bj bj plus c1 w1 plus dot dot ck wk equal to 0. If we do here, if we send all these vectors in RHS, not all these vectors, sorry, this vector and this vector, okay, to RHS, if we send all from here to there to RHS, we get what we got, C1 W1 in LHS dot dot CKWK, and it will be equal to minus of all these vectors, because in LHS we have plus sign, so it will be minus sign when it goes to RHS. Okay, and if we see here U1 dot dot UM and also V1 to VJ, this vector is a basis for W1 and it is equal to this linear combination. It means whatever we get the vector will be in W1 because it is equal to the linear combination of basis of W1. Okay, it should be clear. So it is in W1. Also C1 W1 dot dot CKWK belongs to W2. Why? Because U1, U2, UM and W1 to WK is a basis for W2. Since it is a basis, so linear combination of these vectors will also in W2. It means it is in W2. Okay, we can take C1 W1 plus dot CK WK plus 0 into U1 plus 0 into UM equal to this vector, and this is in W2, so it will be also in W2. Okay, so it is both in W1 and W2. It means it will be in intersection. So, but we know what intersection has a basis, namely U1 dot dot to UM. We have previously assumed. It means we can write D1 U1 plus dot dot DM UM, which will be equal to this vector because it is in intersection. For some scalars D1 D2 DM, okay, we can get a scalars, but W1 to WK and U1 to UM is Li. Why? W1 to WK and U1 to UM is Li because this is a basis for W2. Remember, it means what? Ci will be 0 from 1 to K and Di will be 0 for 1 to M. So what we got here is all the Ci's is 0. Now the remaining task is to do Aij is 0, Ci's are zeros. So remaining task is to do Ai's are zeros and Bi's are 0. So what we left here? Equation 1 becomes Okay, where the equation 1? This is the equation 1. This is 0. So we got RHS only. So, and that will be uh, A1 U1 plus dot dot AM UM plus B1 B1 2 Bj Bj equal to 0. Minus sign has been taken common out and sent to RHS. Okay, that is the basic thing. But we already know that U1 to UM, B1 to Bj, U1 to UM, B1 to Bj is a basis. And for what? This is basis for W1. We have assumed. Because of basis, it will be Li. And this is Li means A, all the Ai's are 0, all the Bi's are 0. And we have already got that Ci's are zeros. This will imply that U1 to UM, B1 to BJ, and W1 to WK is Li. And it was a spanning of W1 plus W2. Yeah, this will imply what? Dimension of W1 plus W2, and dimension means cardinality of bases, and which is M plus J plus K, M plus J plus K, and that is what we are required to prove. Okay, so we have